All. So myself Evraj and I'm a mechanical faculty working as an assistant professor at SNS College of Technology. So regarding the topic which we are going to discuss today, it is about introduction to the additive manufacturing. So we know that so many kind of manufacturings are there for any kind of output product, whatever the products which we are using, that all products has been manufactured either by through the casting, forging, machining, and other machining operations. So basically, we are using these are the conventional kind of manufacturing methods. Okay, but there is a one more method is there, that is what you call that additive manufacturing, which we are used to manufacture at least for all kind of any kind of difficulty in the complex shapes. All kind of prototype has been manufactured with the help of additive manufacturing. So we know that we having in industry we having a 7 different verticals. That one type is what you call the 3D printing. So for 3D printing we are using coming under the category of additive manufacturing. Okay. So this session, which is entirely I am discussing about the introduction and what are the components of additive manufacturing, how the additive manufacturing can influence to manufacturing the product like a plastic or whatever the other simple lightweight materials which it can be done by using the additive manufacturing. So these are the things which I am going to discuss in this session. So first of all, what is meant by additive manufacturing means, let me say for any manufacturing we can done either by casting or most often we use it to do by forging method. So in these two process, the casting as an it is a material less method. There is no material wastage in the casting, but even though if we make a product through the casting, we have to do some machining process in order to getting this good surface finish. For the same thing, if I'm using a machining process, if you are using the turning or phasing, what are the operations which we done for the metal manufacturing? If you are using that, we can getting so much of scrap that huge amount of material wastage will be there. And also the machining cost involved, the tool cost and the human labor cost, it involves so much of cost to the industry. So in order to overcome that, we just need for a prototype manufacturing. So for example, let me take a medical implantation and tooth and also the human skull, bones and lightweight applications like chassis. These are the some of the applications which we are normally using the additive manufacturing, which we can able to manufacture with the help of rapid prototyping. So this is in additive manufacturing, in simple words we use it to say it is a layer by layer. So the materials which can be either in terms of powder form or either in terms of metal form, which we can able to manufacturing it. And this layer by layer can done the traditional geometry and also the traditional method of manufacturing which we can done. But this layer by layer we have commonly we use it to call it is a 3D printing, and it is used for reducing the material waste. So that is why we have to prefer this additive manufacturing is always a good choice for before the products has been launched in the market. They use it to getting the prototype for a better understanding about their structure and their entire view. And the next one, it is about the historical implication. For example, the historical evaluation, if we are going to speak, this additive manufacturing which can usually start from 1980s. So during 1980, the first additive manufacturing concept has been introduced. And following that, the first invention which has been taken place, that is a 3D printer during 1986. Following that, fused deposition modeling has been introduced in 1989, and 3D system with the help of SLA machine has been introduced in 1992. And after that, in 95, laser melting machine, and in 2001, selective laser sintering, and in 2002, Arcam commercialization, and 2007, CE certified orthopedic implant. And 2010 we just manufactured the 3D human blood vessel, and in 2013 we got a 3D human heart, and in 2016 onwards we can do the mass production of 3D engine parts also. We can use it to manufacture with the help of 3D evaluation. So the 2000 is an industrial adoption, but today there is a production grade application which we are using. Okay, so based upon that we use it to call this drivers. The drivers are the AM, which we can normally we use it to say the drivers of AM. It is coming under customization demand. So according to the requirement by the industry or requirement by the individual, we can able to customize the model for any kind of difficult shape. It can be modeled with the help of 3D printing. So that 3D printing, initially the customization design has been adopted. Following that we are converted the design into STL format. And the rapid prototyping, based upon the shape, based upon the size of the object, which we can prefer this rapid prototyping. And specifically if I going to suggest, this shape is mainly focusing on lightweight structures, and as well as it is used for the cost effective low production. So some of these shapes which we can see in this screen, that is like an it is like a hook, and following that we having a casting machine component, and there is a bumper device which you have seen. So these all kind of lightweight materials or lightweight application, preferably we are using the additive manufacturing for this component. Okay, and the main advantages by using the additive manufacturing, if we going to speak, it is about the high design freedom, which means we can able to make any kind of complicated shapes, even the bridge tower, even the construction of the biggest construction of the apartment, or whatever the current major application, or if you plan to manufacturing the aerospace engines, that even that engine also we can able to make by using the 3D printing. So at present we are using the flexible manufacturing system for attaining the good and smooth production in the particular field like 3D printing area, and also it can reduce the lead times, and also the tooling cost involved, it also has been reduced. So the major plus point for this, using this manufacturing, we can able to make any complicated shapes within a day. So it cannot involve the huge amount of cost or huge highly skilled laborers. It cannot able to getting that kind of persons in this kind of manufacturing. So it is highly economical, and even we can able to start, or we can able to visualize the whatever the designs in our mind, we can able to see as a real-time product. Okay, and the major limitations, if we going to speak, it is slower than mass manufacturing, because since it involves only the less weight, so that is a major thing. And material availability, they are preferably they are using the ceramics oriented metals, and some kind of lightweight materials they are using, and the material availability restrictions also, it is supposed to be very low. And the surface finish they may require for the post processing. So after the production has been done, the surface finish may require their post processing, and also it involves the equipment cost is very high. And here I am planned to give you the assignment in the area of any two milestones of AM evaluation, and also I am planning to give the short quiz which we can going to discuss during the class hours, like a 5 MCQ which I plan preferably. So these applications majorly we are using turbine blades, aerospace like in turbine blades and propeller. In automotive there is a prototype and functional parts which we are using, and in medical implants we are using, and along with that consumer products and the industrial tools which we are using for that. So with this I'm just going wind up this session. Okay, so we will meet on another class. Third lecture, in continuation with the previous sessions, I am going to handle the topic that is sustainability in additive manufacturing. So earlier we have seen what is the procedure for doing the manufacturing technique. How can we able to convert the design into the prototype, what is the in between stages between design and the prototype, how can we list it out their functional stages, and how can we execute the functional stages with the help of CAD model, and how it was very good compared to the conventional manufacturing, in what ways the material can able to contribute for high performance. So these are the things which we can see in my previous sessions. So in continuation with my second lecture, I am going to speak about the sustainability for this session. Okay, so generally sustainability means whatever the material which we can use, it can be permanently available in the earth. We don't need to worry about their material, the materials demand, because in the earth we having so much of materials. It is able to recyclable, and also we can able to use it for any case. Okay, so there is no problem about their material usage, and here we having a minimum material waste, and majorly we are using the recyclable materials for the 3D printing, and most often we use it to make it as an energy efficient when it is compared to the subtractive methods. For example, the good example for subtractive methods, if I am going to do any kind of milling operation or shaping or planing, these are all coming under the category of subtractive methods. But in case of additive manufacturing, the subtractive methods, we are using the materials which it can be recyclable, and it can be reused for the manufacturing. The good example which you have seen, the first one, we are using the PLA as the reference, that is polylactic acid, and following that the 3D printing waste has been heated over that PLA corona makers. So based upon that, we use it to washing their materials and shredding the materials into minute particles, and according to that filament has been winded, which you have seen in this screen. That filament winding, it can be done with the help of wet photopolymerization, and according to the wet photopolymerization, it can be extruded with respect to the compression molding. This compression molding, which it helps to transfer the characterization, and also it can able to perform the testing methods with respect to the type of material which you are using in the particular manufacturing technique, and it can be keep repeated with the help of the viscometry, and as well as the recycling process, and that shredding and extrusion, which can keep repeating their process to carry out their fundamental manufacturing technique. So this is the basic process which we are using for the material identification and the material usage for the additive manufacturing processes, and most often it can be used for the energy efficient performance with respect to their customer requirement. Okay, and for what about the stages of ideate? So since I just discussed about their fundamental manufacturing technique, and how the material can be reutilized, and how the material wastes has been eliminated. So based upon that, how can we ideate the process? So that is an important thing. So here in this screen we just see the first, we have to make it as an idea. That idea can be drawn in the by using the 3D model software. From the 3D model, that component is coming under the slicing category, and in that slicing category, once the component has been readed well, their structure, their points, and their major lattices point, once it can be readed by the slicing software, and it can giving the command to the filament winding and the resin. The filament will start feeding over the machine, which can keep running with the help of one mechanism. And the resin also parallelly, it can able to ignite the performance. That filament has been getting melted, and so that both the filament and as well as the resin, which it can be transformed, and following that the part will start manufacturing. Okay, once the part has been start manufactured, the final post processing work will be done. So that is what you have seen in the screen at the bottom of the slide. Okay, So based upon that, we are preferring that 3D model and slicing one with the help of the post-processing technique. We use it to manufacturing this process in various different ways. In industrial application, if I since we are already told majority of the lightweight application we prefer the additive manufacturing because the material cost involved in this manufacturing is very less, and also the manufacturing involves it doesn't need so much of skill to make the complicated shape, because since it can use it to make like a light applications like turbine blades, propellers, and chassis, and as well as the bumper device, and also that body of the vehicle, and flight wings, and human tooth, and along with that in medical implementations or medical installations it can be used. So majorly the bone manufacturing. So these are the areas which they are usually we need to manufacture in the components in that way. Okay, in specific, if we speak about in aerospace, engine components and brackets are the major components which can be manufactured by using the additive manufacturing. And following that, in the automotive products, if we're going to speak, jigs, fixtures, prototypes, these are the major applications area which we can done by using the additive manufacturing in the automotive production. And if you are speaking about the medical, implants and prosthetics, tooth, bones, and skull, and also some kind of hand prosthetics, and these are the devices which we usually we need to make for the medical applications. And if you're going for the consumer goods, preferably the electronics and wearables has been used. In the consumer goods, majority of the electronic devices like resistor, capacitor, diodes, and also circuit board, all kind of manufacturing has been done with the help of the additive manufacturing, so that the electronic devices will keep working with the long lasting condition, and it can able to operate at any kind of temperature areas of application. So that is why the industrial applications has been preferred. Okay, and remaining we will see in next class, and thank you so much for your patience listening.